Now you must have heard about this, especially if you're familiar with machine learning terms. This is basically an optimization method for ML models, and it's a pretty powerful optimization method. Basically, in very high terms, what it does is, you remember the cost function? It takes the partial derivative of this cost function with respect to its variables or weights. Basically here it's going to take the derivative with respect to m and c, in our case for linear regression we need to optimize for m and c, which is why we are taking the partial derivative for both of these variables. And gradient descent basically takes this cost function and calculates the partial derivative, right? And let's say our cost function is something like this. So this is a 2D plane, this is our cost function, what gradient descent does visually is, first we initialize a random point for these m and c values, which is slope and bias, right? Gradient descent gets the slope of this function in a way where it gives us a direction of the optimization. So gradient is actually a slope with respect to this point, and gradient usually gives us the steep or the ascent. What we want to do is go in the opposite direction, because remember this is our cost function and we want to minimize our cost function. To minimize our cost function we want to go down and get to this point. This is our optimal point. Just gonna mark it with orange because this is our optimal point. We want to reach here. Initially we start with a point which is here, and when we calculate the gradient descent at this point it will give us something that goes down in this direction. And then once we come here, this is the new point that we get, which is, let's say, M2 and C2. These are the values we get after one step of gradient descent. We want to continue doing this till we get to the optimal point. So again, at this point we calculate its gradient, and the gradient here will be something like this. We want to calculate the gradient at this point again, and so this point will give us a gradient, and the slope will be this, and we want to go down in the opposite direction, so this will be our gradient descent. And basically we continue doing that till we come down at the optimal point. Now we get the direction by gradient descent. Hope you've understood the concept behind gradient descent. Gradient descent basically gives us the direction of the update. And it tells us which way will lead us to the optimal value for this function, which is basically to minimize the cost. But what actually determines the value that we subtract from our current point or add to our current point is the learning rate. Now, learning rate is a hyperparameter, which basically means we can tune it. It's something that we decide while building our model. And what it does basically is, let's say we give it a value of 0.2. This learning rate tells us how much will we update our weights. And by how much, I mean it controls the size of the weight updates. So what it does is basically controls the size of the weight update, where we get the update, the actual update from gradient descent. So let's say we get this from gradient descent, but the size is what we get from the learning rate. So basically, gradient descent plus learning rate gives us the update of our variables or parameters. And this is exactly how we update our cost function. So let's say on a high level overview, I'm going to summarize this, is we have our cost function, right? Initially we have a set of randomly initialized weights, and by weights what I mean is for our slope m and c bias for our linear regression function, but in general we'll call it weights. So the cost function has initially a randomly set of weights, and how we optimize this is by going through the process of gradient descent, which is basically calculating the gradients and calculating the opposite direction of the gradient, plus the learning rate, which will give us the size of the optimal update at that given point, and then we update the parameters or the weights and compute the cost again. And basically we keep doing this part, which is basically compute the cost, and this part where we update or optimize the weight. At a given point, we keep doing both of these steps till we are satisfied with the result of our model, which is basically till we are satisfied with the predictions it's making. So for example, if we say our given example was, if y is the salary and x is their years of experience, we want the model to perform at a level where if we just give the salary of our person, which is the x, it should give us a reasonable prediction. Sorry, if x is the years of experience, it should give us a reasonable salary corresponding to that years of experience in a given domain. And this is obviously domain specific, and our data set would also be domain specific. But within a domain, if we have a new data point, which is the years of experience of any given employer or person, we should be able to reasonably predict their salary for a given role.